Good morning everyone. I am Tanushree Dai from Civil Engineering branch. In the last class, we have completed our 5th chapter and today we will start with our chapter 6, which name is Design of Tubular Structure. So first of all, we need to know what do you mean by tubular structures and how it's formed. So first of all, tubular sections are the most efficient section for some of the structural elements. That means we can't use the tubular structure in every construction work. It is very rare to use the tubular structure and make a high-rise building with the material type of steel. So we saw a lot of demerits of the tubular structure. So that's why in the past decades their use was restricted for the following reasons. So the first reason is it was difficult to have a smooth cut surface. That means whenever you give a cut to provide the tubular section according to the design purpose, the surface were not as much smooth, which is a big reason for the restriction. And the second reason is it was difficult to cut the tube ends to a correct profile for making joints between steel tube at angles. That means for the uneven surface it is difficult to give an angle and it is a big problem to join two tubular section and form a section. So that's why for these reasons the use of tubular section was restricted in past decades. Then the first two problems were overcome with the development of the oxyacetylene cutting machine. That means according to the use of oxyacetylene cutting machine, we got a smooth surface of the steel tube structures, which is very helpful for the construction work. Then which cuts the surface to the correct profile, leaving a beveled edge and facilitate welding operation. So for the connection of tubular sections, we have to use only welding type of connection. So now, as per the IS 1161-2014, some welding type of connection is there. So these are HFW, that means hot finished welded type. Next type is HFS, that means hot finished stainless type. The last one is ERW, that means electric resistance welded or induced welded. So now where this kind of welding is provided. So first of all, the HFW, that is high frequency welding, is mainly used in ordinary or thin wall steel pipe. Okay. Then next one is your HFS, that is hot finished seamless mechanical tubing, is a 1020 by 1026 carbon seamless mechanical steel tube. Then third one, which is ERW, which is commonly used and produced from a rotation heater bar electric resistance, which is general designation for resistance welded steel pipes. Then now comes to the classifications of the tubular structures. So according to the wall thickness, the tubular structures are majorly divided into three types. First one is your light tubular structure, second one is your medium tubular structure, and third one is your heavy tubular structure. So these are categorized into three types as per the wall thickness. And another categorization is according to the yield stress of the tubular structure. So according to yield stress, these are three types. So first one is your YST210, or it is known as ST35, or it is known as YST22. So these are the grade of the tubular structures, you can see, in which the tensile strength is 3300 kg per mm square and yield stress will be 210 Newton per mm square. So this is one type. Then second type is YST240, or you can say ST40, or you can say YST25, where the tensile strength will be 4100 kg per mm square and yield stress will be 240 Newton by mm square. And the third type will be YST310, or you can say ST55 or YST32, where the tensile strength of YST310 is 4500 kg per mm square and yield stress is 310 Newton per mm square. So these are all about the classification of the tubular structure. So now comes to the some tubular structures in the world. So the first figure is Wills Tower, which is situated at the foreign country and it is completed in 1973 and it is the world's tallest building until 1998, and after 1998 Burj Khalifa is the one of the tallest building in the world. So next figure is the John Hong Kong Center in Chicago. It is situated at Chicago and it is completed in 1969. And it is a truss kind of member used and all the members are tubular sections member. So now this figure will be the Burj Khalifa, which is known as the tallest building in the world, which height is 829.8 meter and it is inaugurated at 2010 in Dubai. So next figure is your Jin Mao Tower, which is also known as Jinamo Building or Jin Mao Tower. It is an 88-story building which is situated at China, Shanghai. So these are some tubular structures in the world. So now comes to the some advantages and disadvantages of the tubular sections. So tubular steel structures are the best alternative to conventional structures for their practically and good performance. Obviously, due to the cross-sectional profile of the tube, the weight may be reduced by many structural members. So first of all, the advantages part. For the tubular structures, a higher strength to weight ratio can be set up to 30% in steel. The next advantages is due to the high torsional stiffness, the compressive strength of the steel pipe more efficient than conventional steel section. So it is a big advantages for the tubular section. The next advantages is for dynamic loadings, the vibration frequency of the pipe is higher than any other rolling section. And last of the advantages is easy to maintain. No angularity is there, easy to manufacture and install also. So these are all about the advantages of tubular structures. Now comes to some disadvantages. As we know that the connection part is somehow very big problem in the construction work. So first of all, it has high manufacturing cost. Second one is the disadvantages is that connection between tubes are more difficult to make than from plate or hot rolled sections. The materials used for the tubular structures includes circular hollow sections, which is known as CHS, and rectangular hollow sections, that is RHS, and square hollow section, that is SHS. So these are all about your advantages and disadvantages of the section. So now comes to the design procedure of the tubular sections. So as I told you before, the tubular sections can be used as the compressive member as well as the tension member, because most of the time these sections are used for the truss making and also the roof making works, where rafter type of sections also used as a tubular type sections. So for the compression member, the design procedure is different, and where we have to connect two members, that is compression and tension member, get together to form a structure. That time the design procedure quite separate as compared to the only compression member. So that first of all we have to design the tubular section for the compression member only. So here in the step 1, first of all you need to write down all the data given which is already provided in your question. Then according to the section we have to find out all the properties, and you can get these properties from the IS code 1161/2014. Then in step 2 we need to calculate the slenderness ratio, as we know that the slenderness ratio is equal to the ratio between effective length to the radius of gyration. So the radius of gyration value you can find out from the section properties, that is from the code 1161/2014. And as per the end condition we can find out the effective length value of the compression member. Now in step 3 we have to calculate the permissible stress in compression member, which is denoted as FC value. So here according to the slenderness ratio we have to find out the FC value from the IS code 806/1968 table number 2. So from that you can get the value of FC for your appropriate slenderness ratio. Then in step 4 we have to calculate the safe load carrying capacity, that is denoted as P, by putting the formula, that is A into FC, where A is the cross-sectional area of the tubular section and FC is the permissible stress in compression. So A value you can get from the IS code 1161, where you write all the properties of the section. So in this way your compression member design is completed. So today this much. We will discuss rest of the thing in the next class. Thank you.